In this video, we discuss how to work with compound and inequalities, also known as conjunctions. So here we have x greater than 2 and x less than or equal to 5. So these are two inequalities, and because of the way they're being joined together with the and, they simultaneously have to be true. So we're looking for all the x that are both greater than 2 and less than or equal to 5. So the way we do that is we graph both of the inequalities. So for the x greater than 2, we'll put a 2 on the number line, and then we'll shade everything to the right of 2 because it's greater than 2. And because it's strictly greater than 2, we'll have a parenthesis. Then we'll graph all of the x that are less than or equal to 5. 5 is there, so if it's less than or equal to 5, we'll shade to the left, get all the numbers that are less than 5 with an arrow there, and then we know we have a bracket because it's less than or equal to 5. So with the conjunction, what we're doing is we're looking at all of the numbers that are that solve both of those sets, both of those inequalities. So it's the overlap. So everything in between those two numbers will be simultaneously greater than 2 and less than or equal to 5. So if we look at the overlap there, it's all the numbers between 2 and 5. So that's the graph. To write it in interval notation, we'll have our two numbers, 2 and 5. Those are the endpoints. 2 is not included, 5 is included. So this is the interval notation. The next one is a little more work because we have to solve each inequality first. So let's solve that x plus 7 less than or equal to 10 minus 4. So 10 minus 4 is 6, so we'll move that 7 over by subtracting. So that'll be all of the x that are less than or equal to negative 1. Then we'll do the same with 5x minus 7 greater than or equal to 3. We'll add the 7 over. So that'll be 5x greater than or equal to 10. And then to get rid of the 5, we divide both sides by 5. So again, this is an and, it's a conjunction. So we're looking for all of the x that are simultaneously less than or equal to negative 1 and greater than or equal to 2. So what we'll do is we'll graph all of the x less than or equal to negative 1, so that'll be to the left, and it's a bracket because it's less than or equal to. Then we'll graph all of the x greater than or equal to 2, so there's 2, so if we're greater than or equal to 2, we're to the right, another bracket there. Notice that there is no overlap here. The conjunction is all of the points that satisfy both inequalities. Well, there is no number that's simultaneously less than negative 1 and greater than or equal to 2. So since there's no overlap here between the two sets, there is no solution. So we can write no solution. Another way is this symbol here, the empty set notation. And we have a couple more, so we'll do the same. We'll solve by isolating x, so we'll move that 6 over, and we'll divide through by the 4 on both sides, so we'll simplify the fraction there, so 7 halves. Then on this one, we'll move all the x's to one side, then we divide both sides by the negative 5. So it gives us a negative 4. Of course, we have to flip the inequality. So now we'll graph both of those inequalities. So we want all of the x that are less than 7 halves. Less means to the left. So we'll shade to the left. Then we'll have another graph for x less than or equal to -4, so that will be a bracket at -4, and then we're looking for all of the numbers that solve both of these inequalities. So what numbers are in both of these graphs? Well, again, it's the overlap of the two graphs. So the overlap is all of these numbers less than or equal to -4. So we've solved it. This is solving, where we isolate x, then we graph it, and then we write it in interval notation. So we have the left endpoint, well, it goes to -infinity. Then we have the right endpoint, -4. We see our bracket there, and we always have a parenthesis around infinity. So that last part there is the interval notation solution. On this one, same process, we'll isolate x. So here we can multiply or divide both sides by -1. Of course, we flip the inequality. Then move the 1 over, divide both sides by 2. So we've solved each one, but now we have to join the two sets by using the AND operation. So this is an intersection of the two sets. So we'll graph the first one, all of the x greater than or equal to -5. And then we'll graph the second one, all of the x less than 7/2. And we're looking for the overlap. So the overlap would be everything between -5 and 7/2. So we've solved it at this point here by isolating x in both of the inequalities. Then we have our graph here, the graph of the solution set, and then to write it in interval notation, it's the leftmost number, comma, rightmost number, and we follow the graph with a parenthesis and a bracket on the left. Conjunctions and compound inequalities can sometimes be written in this three-part format. When it's written in this format, it's understood to be an AND inequality. So if we look at this, what it's saying is it's all of the x that are simultaneously greater than or equal to 9 and less than or equal to 1. Since x is already isolated, we can go right to the graph. It's this one right here. So if we use the closed dot notation, we have the closed dots, and it'll be everything between -9 and 1. On the next example, there's a little more work to do because we have to isolate x in the middle. So we'll get rid of the 2 by subtracting 2 from all of the 3 parts of the inequality. And then we'll divide through by the -4. So we divide each of the 3 by -4. Since we were dividing by a negative number, we have to flip all of the inequalities. So now x is isolated in the middle. It's saying the solution set is all of the x values that are simultaneously greater than 0 and less than or equal to 2. So we can go right to a graph here. We know we're going to have 0 and we're going to have 2. We're not including 0, so it's a parenthesis at 0. We are including 2, so we have a bracket at 2, and then it'll be all of the numbers between 0 and 2 for our graph. So we've solved it at this point by isolating x, and then we graph it. This is our graph, and then writing it in interval notation is usually pretty straightforward. Once you have the graph, we have 0 on the left, 2 on the right, with a parenthesis and a bracket. And then for our last example, we'll isolate x again, so add 8 to all 3 parts. Then we'll divide through by the 3. X is now isolated, so it's solved. To graph, it's pretty straightforward. It's going to be all of the x between -1 and 5, but we're including -1, so that should be a bracket there. So we have a bracket at -1, we have a parenthesis at 5 because 5 is not included. That's the graph, and then to write it in interval notation, we have our left number, we have our right number, bracket at the left end, parenthesis at the right end.